The Mathematical Certainty of Aerial Annihilation, October 7, 1943. The Coral Atolls of Rabaul, New Britain. Lieutenant Commander Hiroshi Nishizawa, the greatest ace in the Imperial Japanese Navy with 63 confirmed kills, stood beside his Mitsubishi A6M50 and laughed. The sound carried across the humid morning air as he read the intelligence report that had just arrived from the Solomons. The Americans, it seemed, had deployed a new fighter, something they called the F6F Hellcat. According to the captured pilot testimony, it was heavy, brutish, and ungainly. Like trying to dogfight in a freight train, the American had supposedly said before his interrogation ended. Nishizawa folded the report and tucked it into his flight suit. He had faced every fighter the Americans had thrown at him. The chunky F4F Wildcats that fell like stones. The twin-boomed P-38 seconds that broke apart under sustained fire. The stubby F4U Corsairs that couldn't match a Zero's turning radius. Now they wanted him to fear another flying brick? The man they called the Devil of Rabaul climbed into his cockpit, his mind already calculating the angles and energy states that would send this new American machine tumbling into the Solomon Sea. He could not know, as he taxied toward the runway in the pre-dawn darkness, that he was witnessing the last sunrise of Japanese aerial supremacy in the Pacific. What Nishizawa didn't understand, as he pulled back the stick and felt the Zero's familiar lightness carry him into the tropical sky, was that mathematical certainty was already loaded in the wings of every Hellcat rolling off the production lines in Connecticut and New York. This wasn't merely the introduction of another fighter aircraft. It was the manifestation of industrial annihilation, a weapon forged not just in aluminum and steel, but in the overwhelming abundance of American manufacturing capacity. The F6F Hellcat represented something more terrifying than superior firepower or advanced technology. It was the physical embodiment of a nation's ability to systematically manufacture victory through the relentless application of resources, engineering precision, and the cold mathematics of mass production. While Japanese pilots tested their skills against individual opponents, America was preparing to bury the entire Imperial Japanese Navy Air Service under an avalanche of Hellcats so massive, so technically superior, and so numerically overwhelming that resistance would become not just futile, but mathematically impossible. The numbers began to tell their story even before the first Hellcat engaged its first Zero in combat. When Grumman Aircraft Engineering Corporation received the Navy contract for the F6F in May 1941, their Bethpage facility on Long Island was already producing one F4F Wildcat every 8 hours. Within 18 months, as the first production Hellcats rolled off the assembly line in October 1942, Grumman had systematically redesigned their entire manufacturing process around a single, devastating principle: the creation of aerial superiority through industrial overwhelm. The Bethpage plant alone was producing one complete F6F every hour by early 1943, but this represented merely the beginning of America's aerial mathematics. Eastern Aircraft, General Motors' newly created aircraft division, retooled their former automobile plants in New Jersey to produce Hellcats under license. By the summer of 1943, as Nishizawa prepared for his final combats, the combined production rate had reached one F6F every 37 minutes, every hour of every day, around the clock. The contrast between American and Japanese production capabilities revealed itself in statistics so overwhelming they bordered on the incomprehensible. Japan's total aircraft production for the entire year of 1943 would reach 16,693 machines of all types: fighters, bombers, trainers, reconnaissance aircraft, and transports combined. In that same year, American factories would produce 12,571 F6F Hellcats alone, representing nearly 75% of Japan's total aviation output in a single fighter type. But the true magnitude of American industrial dominance lay not in these raw numbers, but in the systematic efficiency with which each Hellcat was engineered, produced, and deployed. While Mitsubishi's Nagoya plant employed teams of skilled craftsmen to hand-fit each Zero's components, requiring 15,000 man-hours to complete a single aircraft, Grumman's production line utilized precision tooling and standardized assembly techniques that reduced the F6F's construction time to 8,200 man-hours, nearly half the labor investment required for each Zero. Yet production speed represented only the beginning of the Hellcat's mathematical superiority. Where the A6M0 had been designed as a masterpiece of weight-saving engineering, sacrificing armor, self-sealing fuel tanks, and structural redundancy for maximum agility, the F6F embodied an entirely different philosophy of aerial warfare. The Hellcat's design specifications called for an aircraft that could absorb punishment that would annihilate a Zero and continue fighting. The Zero's total weight of 5,313 pounds when fully loaded seemed almost ethereal compared to the Hellcat's 15,413 pound maximum takeoff weight. This wasn't inefficiency, it was insurance. Every one of those additional 10,100 pounds served a purpose. 212 pounds of armor plating protecting the pilot and critical systems. Self-sealing fuel tanks that could survive multiple cannon strikes. A radial engine so robust it could operate with entire cylinders shot away, and a structural frame capable of withstanding G-forces that would tear a Zero apart. The engines alone told a story of technological overwhelm that Japanese engineers could barely comprehend. The Zero's Sakai radial engine, a masterpiece of Japanese engineering, produced 1,130 horsepower and weighed 1,260 pounds, a remarkable power-to-weight ratio that enabled the aircraft's legendary maneuverability. But the Hellcat's Pratt Whitney R-2800 double wasp represented American engineering philosophy in its purest form. 2,000 horsepower of raw, mechanical dominance housed in an engine that, despite weighing 2,360 pounds, delivered nearly double the Zero's power output. The R-2800 didn't merely power the F6F, it overwhelmed every aspect of aerial performance that mattered in modern combat. Maximum speed, 380 miles per hour for the Hellcat versus 350, one for the Zero. Rate of climb, 3,240 feet per minute versus 3,100. Service ceiling, 37,300 feet versus 36,200. In every measurable category except turning radius, the Hellcat possessed mathematical superiority. But the most crushing advantage lay in armament, where American abundance transformed aerial combat from a battle of skill into an exercise in overwhelming firepower. The standard Zero carried two 7.7mm machine guns mounted in the engine, cowling, and two 20mm cannon in the wings, a total of 340 rounds per minute of sustained fire. The armament was precise, effective, and perfectly adequate for the lightweight fighters it had been designed to engage. The F6F Hellcat mounted six 50-caliber M2 Browning machine guns, each capable of firing 800 rounds per minute, delivering a combined weight of fire of 4,800 rounds per minute, more than 14 times the Zero's sustained firepower. Each 50-caliber round weighed 1.67 ounces and delivered 13,400 foot-pounds of muzzle energy, compared to the Zero's 7.7mm rounds at 0.44 ounces and 1,650 foot-pounds. The mathematical reality was stark. A single 2-second burst from a Hellcat's guns delivered more destructive energy than a Zero could produce in 30 seconds of sustained fire. The production of ammunition revealed the depth of American industrial preparation for total aerial warfare. Lake City Army Ammunition Plant in Missouri, built specifically to supply 50-caliber ammunition for aircraft applications, was producing 1.5 billion rounds annually by 1943. This represented enough ammunition to supply every F6F Hellcat in the Pacific, with 15,000 rounds per aircraft, more than the entire Japanese military could produce in all calibers combined. Each Hellcat carried 2,400 rounds of ammunition as standard load, enough for sustained combat that would exhaust the ammunition supplies of an entire Japanese squadron. The psychological impact on enemy pilots was devastating. While Zero pilots learned to conserve ammunition and fire only when certain of a hit, Hellcat pilots could engage targets with overwhelming suppressive fire, knowing that their ammunition supply was essentially limitless. The pilot training programs that supported these aircraft revealed another dimension of American systematic dominance. Japanese naval aviation had developed a highly selective system that identified potential pilots through rigorous physical and mental testing, then subjected them to years of intensive training. The program produced exceptional aviators, men like Nishizawa and Sakai, who possessed almost supernatural flying abilities, but the system could not scale. Japan graduated fewer than 100 new naval pilots per year through 1942, and even when the program was dramatically expanded in 1943, production peaked at 180 pilots annually. The quality remained extraordinary, but the quantity was catastrophically inadequate for sustained warfare against an industrial power. America approached pilot training with the same systematic efficiency it applied to aircraft production. The Navy's aviation training program graduated 1,500 new pilots in 1940. By 1943, the system was producing 2,400 new naval aviators every month, more than Japan could train in an entire year. The American pilots might lack the individual artistry of their Japanese counterparts, but they were trained in tactics specifically designed to exploit the Hellcat's advantages while minimizing its weaknesses. The Thatch Weave, developed by Lieutenant Commander John S. Thatch, turned American numerical superiority into tactical dominance by coordinating multiple aircraft in mutually supporting defensive patterns. Japanese pilots, trained in individual combat and reliant on their aircraft's superior maneuverability, found themselves systematically outmaneuvered by American formations that could concentrate overwhelming firepower against single targets. The fuel situation revealed perhaps the most devastating aspect of America's mathematical advantage. Each F6F Hellcat carried 250 gallons of aviation gasoline as standard load, with provisions for external fuel tanks that could extend range to over 1,000 miles. The fuel was 100-octane aviation gasoline, refined specifically for high-performance engines and available in unlimited quantities from American refineries. Japan, by contrast, was already rationing aviation fuel by early 1943. The Standard Zero carried 156 gallons of fuel adequate for extended patrols and combat, but Japanese petroleum imports had been strangled by American submarine warfare. The aviation gasoline available to Japanese pilots was increasingly diluted with lower-octane substitutes that reduced engine performance and reliability. Pilots reported engines failing during high-G maneuvers, reduced climb rates, and decreased maximum speeds as fuel quality deteriorated throughout 1943. The industrial infrastructure supporting the Hellcat program demonstrated America's ability to wage total war through systematic resource allocation. Aluminum production in the United States reached 2.4 million tons annually by 1943, compared to Japan's total of 154,000 tons. Each F6F required approximately 2.8 tons of aluminum alloy, meaning American aluminum production could theoretically support 857,000 Hellcats per year based on raw materials alone. Japan's entire aluminum output could support fewer than 55,000 Zeros, and most of that aluminum was required for other military applications. The shortage forced Japanese engineers to substitute steel components wherever possible, adding weight and reducing performance. Some late-war Zeros incorporated wooden components as aluminum became unavailable, further degrading structural integrity and flight characteristics. The electronic systems installed in each Hellcat represented technological advantages so comprehensive they bordered on science fiction compared to Japanese capabilities. The standard F6F carried an SCR-522 VHF radio system that provided crystal-clear voice communication over ranges exceeding 100 miles. The radio enabled real-time coordination between aircraft, vectoring by ground controllers, and immediate tactical adjustments during combat. Japanese fighters typically carried Type 96 radio systems with ranges of 15 to 20 miles, and voice quality so poor that most communication relied on hand signals or predetermined flight patterns. American pilots could coordinate complex tactical maneuvers, call for assistance, and receive vectoring to enemy formations. Japanese pilots often flew into combat without knowing the location, composition, or intentions of friendly forces more than a few miles away. The radar integration that became standard on late production Hellcats introduced capabilities that Japanese pilots could barely comprehend. The APS-6 airborne intercept radar, while primitive by later standards, could detect aircraft at ranges of 5 to 10 miles and provide bearing and distance information directly to the pilot. Night fighting, previously the domain of specialized aircraft and exceptionally skilled pilots, became routine for Hellcat pilots equipped with radar. Japanese aircraft possessed no airborne radar systems, making night operations extremely hazardous and largely ineffective. American night fighter squadrons operating radar-equipped Hellcats achieved kill ratios exceeding 20-1 against Japanese aircraft attempting nocturnal attacks. The maintenance and logistics systems supporting Pacific-based Hellcat operations revealed the depth of American industrial planning for sustained combat operations. Each F6F was designed for maintainability, with standardized components, accessible systems, and comprehensive technical documentation. The average turnaround time for routine maintenance was 4.5 hours, compared to 12 to 15 hours for a zero-receiving equivalent service. American maintenance teams were equipped with precision tools, abundant spare parts, and detailed technical manuals. Japanese maintenance crews often improvised repairs using hand-fabricated parts, salvaged components, and maintenance procedures passed down through verbal instruction. The spare parts supply chain demonstrated American logistical dominance in quantifiable terms. Each deployed Hellcat squadron was supported by inventory stocks equivalent to 200% of the parts required to completely rebuild every aircraft in the unit. Parts availability exceeded 98% for all major components, meaning mechanical failures rarely resulted in extended aircraft downtime. Japanese squadrons typically operated with parts availability below 60%, and many aircraft were cannibalized to keep others operational. By late 1943, some Japanese units reported effective aircraft availability rates below 40% due to parts shortages, mechanical failures, and maintenance delays. The combat debut of the F6F Hellcat against Japanese forces revealed the mathematical certainty of aerial annihilation in its purest form. On August 31, 1943, Hellcats from USS Essex encountered Zero fighters over Marcus Island in the first major engagement between the two aircraft types. The results were immediate and devastating. 12 Zeros destroyed, no Hellcats lost. September brought expanded combat as more Hellcat squadrons entered the Pacific theater. The monthly kill ratio reached 8, 1 in favor of the F6F, a figure that would steadily increase as American pilots gained experience with their aircraft's capabilities. October 1943 marked the beginning of systematic aerial annihilation as Hellcat squadrons began operating in large formations over the Solomon Islands. The Japanese response revealed the futility of individual skill against mathematical superiority. Ace pilots like Nishizawa and his wingmen could still achieve victories through superior tactics and experience, but the overall statistics were inexorably shifting. For every Zero that successfully engaged and destroyed a Hellcat, American production lines were delivering 5 new F6Fs to Pacific squadrons. Japanese aircraft losses were irreplaceable. American losses were absorbed by production capacity so vast that combat attrition was statistically insignificant. The Battle of the Philippine Sea in June 1944 demonstrated the ultimate expression of the Hellcat's mathematical dominance. Admiral Jisaburo Ozawa launched 473 aircraft against the American fleet in what became known as the Great Marianas Turkey Shoot. Hellcat squadrons from 15 aircraft carriers met the attack with 450 fighters, engaging in the largest carrier-based air battle in history. The results were catastrophic for Japanese aviation. 395 aircraft destroyed, 445 aircrew killed or missing. American losses totaled 29 aircraft, with 27 aircrew recovered. The kill ratio of 13.6-1 represented not merely tactical victory, but the mathematical elimination of Japanese naval aviation as an effective fighting force. Individual combat reports from the Philippine Sea engagement revealed the mechanical precision with which Hellcats systematically destroyed their opponents. Lieutenant J.G. Alexander Vrasiu of VF-16 encountered a formation of 18 Japanese dive bombers and destroyed 6 aircraft in a single 8-minute engagement. His combat report described each kill in clinical terms. First target destroyed by burst into engine section. Aircraft exploded. Second target destroyed by burst into fuel tank. Aircraft caught fire and crashed. Third target. The report continued with mechanical precision, documenting the systematic destruction of aircraft that Japanese industry could not replace. The psychological impact on surviving Japanese pilots was documented in intelligence reports and captured documents that revealed the depth of demoralization within the Imperial Navy Air Service. Flight Petty Officer Kiyoshi Ota, shot down during the Philippine Sea battle and captured by American forces, provided testimony that summarized the Japanese perspective. We were told the new American fighter was heavy and slow, that our superior skill and aircraft would overcome their numbers, but they are not slow, and they are not clumsy. They are like flying fortresses that cannot be shot down, and they are everywhere. For every one we destroy, 10 more appear. It is like fighting the ocean itself. The production statistics for 1,944 revealed the complete mathematical impossibility of Japanese aerial resistance. American factories delivered 12,272 F6F Hellcats that year, while Japanese production of all fighter aircraft totaled 13,811 units. The Americans were producing nearly as many of a single fighter type as Japan could produce of all types combined. But the true significance lay in the cumulative effect. By December 1944, a total of 18,156 Hellcats had been delivered to the Navy and Marine Corps, compared to approximately 10,500 Zeros produced since the beginning of the war. American industry had not merely achieved parity, it had surpassed total Japanese fighter production with a single aircraft model. The technical evolution of the Hellcat throughout 1944 demonstrated America's ability to continuously improve its weapons systems while maintaining massive production rates. The F6F5 variant introduced in March 1944 incorporated more powerful armament options, improved armor protection, and enhanced electronic systems. Water injection for the R-2800 engine increased maximum power to 2,200 horsepower for emergency situations. Some variants carried 20mm cannon, rockets, or bombs, transforming the fighter into a multi-role weapons system. Japanese aircraft, constrained by limited industrial capacity and raw material shortages, showed little evolution beyond the basic A6M5 design. Attempts to develop improved variants were hampered by aluminum shortages, fuel quality problems, and the diversion of engineering resources to more pressing needs. The pilot experience differential had become mathematically decisive by late 1944. American Hellcat pilots averaged 300 hours of flight training before combat deployment, with many receiving additional combat training on older aircraft types before transitioning to the F6F. Japanese pilot training had been reduced to fewer than 100 hours due to fuel shortages and the urgent need for replacement pilots. The reduction in training quality compounded the technical disadvantages of Japanese aircraft. Inexperienced pilots could not exploit the Zero's remaining advantages in maneuverability and often fell victim to basic tactical errors that experienced pilots would have avoided. The fuel crisis that gripped Japanese aviation by 1944 eliminated many of the operational advantages that had previously offset technical inferiority. Japanese pilots were restricted to essential missions only, with training flights virtually eliminated. Patrol flights were reduced to minimum duration, and complex tactical maneuvers were avoided to conserve fuel. American pilots, supported by unlimited fuel supplies, could train extensively, conduct long-range patrols, and engage in extended combat without concern for fuel consumption. The average Hellcat pilot accumulated twice as much monthly flight time as his Japanese counterpart, creating an expanding gap in operational proficiency. The night fighting capabilities that became routine for Hellcat squadrons in 1944 represented a technological dimension of aerial warfare that Japanese forces could not counter. Radar-equipped F6F night fighters achieved a 95% mission success rate against Japanese night bombing attempts, effectively ending nocturnal attacks as a viable tactic. The psychological impact was severe. Japanese pilots, who had previously relied on darkness for protection, found themselves systematically hunted by invisible opponents with technological capabilities they could not comprehend or counter. The destruction of Japanese training facilities and aircraft by late 1944 eliminated the possibility of recovering aerial competitiveness through expanded pilot production. American bombing raids systematically targeted Japanese flight training schools, destroying aircraft, facilities, and instructors. The remaining training programs were relocated to increasingly remote locations with minimal facilities and inadequate aircraft. Many Japanese pilots received their final training on aircraft so worn or damaged that they were barely airworthy, creating a generation of aviators whose combat effectiveness was compromised before they ever engaged the enemy. The mathematical progression of Hellcat dominance reached its logical conclusion during the final year of the war. Kill ratios that had begun at 8:1 in favor of the F6F steadily increased as Japanese pilot quality declined and American tactical proficiency improved. By early 1945, Hellcat squadrons were achieving kill ratios exceeding 15:1 in most engagements. Some individual actions produced ratios approaching 20:1, as American pilots encountered formations of inexperienced Japanese pilots flying worn-out aircraft with minimal fuel and ammunition. The kamikaze campaigns of 1945 represented a tacit admission of the mathematical impossibility of conventional aerial combat against Hellcat-equipped squadrons. Japanese commanders, recognizing that traditional dogfighting had become suicidal for their pilots, redirected their remaining aircraft towards suicide attacks against American naval forces. Even this desperate tactic was systematically countered by Hellcat combat air patrols that intercepted and destroyed kamikaze formations before they could reach their targets. The F6F's superior speed, climb rate, and firepower made it ideally suited for intercepting heavily loaded attack aircraft that sacrificed maneuverability for explosive payload. The final Japanese ace pilots who survived to face Hellcat squadrons in 1945 provided testimony to the overwhelming nature of American aerial dominance. Chief Petty Officer Kaneyoshi Muto, one of Japan's highest-scoring surviving aces with 28 victories, was shot down by Hellcats in March 1945 during a combat over Okinawa. His post-war interview provided a professional pilot's assessment of the tactical situation. By 1945, engaging American fighters in conventional combat was suicide. Their aircraft were superior in every measurable way except turning radius, but they had learned not to engage in turning battles. They would attack in formations of 8 or 12 aircraft, using superior speed and climb rate to control the engagement. If we tried to escape, they were faster. If we tried to climb, they climbed better. If we tried to dive away, they followed and caught us. There was no tactical solution to their advantages. The production figures for the final year of the war demonstrated the complete futility of Japanese resistance against American industrial capacity. In 1945, American factories produced 7,870 additional Hellcats before production ended in November, bringing the total F6F production to 12,275 aircraft. Japanese fighter production for the entire year totaled fewer than 5,000 aircraft of all types, many of them using substitute materials that compromised structural integrity and performance. The mathematical relationship was clear. American production of a single fighter type exceeded Japanese production of all fighters combined, and the American aircraft were superior in every measurable category. The technological gap between American and Japanese aircraft had become so vast by 1945 that captured Japanese pilots often expressed astonishment at the capabilities of American equipment. Lieutenant Saburo Sakai, Japan's second highest scoring ace, encountered Hellcats during the defense of Japan in 1945. His post-war memoir described the technological shock. "I had flown against every American fighter type since Pearl Harbor. I thought I understood their capabilities and limitations, but the late-war Hellcats were like flying computers compared to our aircraft. They had radios that worked perfectly, radar systems that could find us in any weather, and weapons that could destroy any Japanese aircraft with a single burst. Fighting them was like trying to use a sword against a machine gun. The strategic impact of Hellcat dominance extended far beyond individual combat victories to influence the entire trajectory of the Pacific War. Japanese commanders, recognizing the mathematical impossibility of achieving aerial superiority against American forces, were compelled to adopt increasingly defensive strategies that ceded initiative to American operations. The combined fleet's inability to provide effective air cover for surface operations eliminated the possibility of major offensive actions after mid-1944. Japanese naval operations were reduced to defensive reactions against American initiatives, with predictably disastrous results. The psychological effect of systematic aerial defeat on Japanese military leadership was documented in intercepted communications and post-war testimonies that revealed the depth of strategic despair within the Imperial Navy. Admiral Jisaburo Ozawa, commander of the Combined Fleet's carrier forces, reported to Imperial headquarters in September 1944, "Our aviation forces have been systematically destroyed by American fighters of superior performance. We lack the industrial capacity to replace our losses or train adequate replacement pilots. Continued conventional operations will result only in the complete elimination of our remaining air strength without corresponding damage to enemy forces." The economic mathematics of aerial warfare had reached a point where Japanese resistance became not merely futile but economically impossible to sustain. Each Zero that engaged a Hellcat in combat represented an investment of 15,000 man-hours, 8 tons of increasingly scarce aluminum, and a pilot trained at enormous expense over many months. Each Hellcat represented 8,200 man-hours, abundant raw materials, and a pilot trained in a system capable of producing replacements faster than combat could eliminate them. The economic exchange rate favored America so overwhelmingly that continued Japanese resistance served only to accelerate their own military collapse. The technical specifications that had once defined aerial combat were systematically redefined by American industrial capacity and engineering superiority. Speed, climb rate, firepower, range, armor protection, electronic systems, maintenance requirements, production efficiency, and pilot training had all shifted decisively in favor of American forces. The Zero, which had represented the pinnacle of Japanese engineering and tactical thinking in 1941, had become obsolete, not through any inherent design failure, but through the systematic application of American technological and industrial advantages. The final engagement between F6F Hellcats and A6M Zeros occurred on August 15, 1945, over the Japanese home islands as American carrier aircraft conducted the last combat sorties of the war. The symbolic significance was profound. American fighters operating with complete impunity over Japan itself, their presence representing the ultimate expression of industrial warfare's mathematical certainties. Japanese fighters that rose to intercept were systematically destroyed by pilots flying aircraft that embodied 4 years of continuous technological improvement and industrial refinement. The mathematical certainty of the Hellcat's dominance over the Zero was not merely a matter of superior engineering or production capacity, though both were decisive factors. It represented the manifestation of two fundamentally different approaches to modern warfare: individual excellence versus systematic superiority, artisanal perfection versus industrial overwhelm, tactical brilliance versus strategic mathematics. The Japanese had created magnificent aircraft flown by exceptional pilots who could achieve remarkable individual victories. The Americans had created a system of systematic annihilation that made individual excellence irrelevant through the application of overwhelming technological and numerical superiority. In the end, the story of the F6F Hellcat versus the A6M Zero became the story of industrial warfare itself. The demonstration that victory in modern conflict is determined not by the courage or skill of individual warriors, but by the mathematical application of industrial capacity, technological superiority, and systematic resource allocation. The Japanese pilots who laughed at early reports of the ungainly new American fighter had failed to understand that they were facing not merely another aircraft, but the physical manifestation of American industrial might configured for the systematic destruction of their air force. The laughter that had echoed across the coral atolls of Rabaul in October 1943 was silenced forever by the mathematical precision of American aerial warfare. Lieutenant Commander Nishizawa, the Devil of Rabaul himself, was shot down and killed by American fighters on October 26, 1944, while flying as a passenger in a transport aircraft that fell victim to a Hellcat patrol. His death symbolized the complete reversal of aerial fortune that had transformed American fighters from laughable targets into instruments of systematic annihilation. The Zero's reign as the Pacific's dominant fighter had ended not in a climactic battle between individual champions, but in the grinding mathematics of industrial production and technological superiority. The 12,275 F6F Hellcats that rolled off American production lines between 1942 and 1945 achieved a combined kill ratio of 19-1 against all enemy aircraft types, with their dominance over the Zero being even more complete. This represented not merely tactical victory, but the systematic destruction of an enemy air force through the overwhelming application of industrial mathematics. The Americans had not simply outfought the Japanese. They had out-produced them, out-engineered them, and ultimately overwhelmed them with a cascade of technological and numerical advantages so comprehensive that resistance became mathematically impossible. The lesson transcended aviation and entered the realm of universal strategic truth. In industrial warfare, victory belongs not to the brave or the skilled, but to those who can systematically apply superior resources, technology, and production capacity with mathematical precision. The F6F Hellcat had swept the Zeros from the Pacific skies not through any single advantage, but through the cumulative weight of American industrial civilization configured for total war. It was a demonstration of power so complete, so mathematically certain, that it redefined the very nature of aerial combat and established the template for technological dominance that would characterize military conflict for generations to come.